All right, first test of the year. Here we go. This is a review. I will go through the video. Obviously, only watch the parts that you need. The answer key is in Canvas as well, so utilize your tools and let me know if you have questions. All right, number one, determine if the variables are quantitative or categorical. We're going to use Q for quantitative and C for categorical. Time it takes to get to school, that is quantitative. The number of shoes owned, that is quantitative. I'm counting something. Hair color, I'm putting things into categories there. Temperature, that is a measure of something. Teachers' salaries, that is a measure of something. Gender, that is categorical. Whether or not we're Facebook user, that is categorical. Height, I'm measuring something, that is quantitative. Amount of oil spilled, that is quantitative. Age, we can go ahead and say that's quantitative. Again, if I put them into age ranges, then that would be categorical. Type of pain medicine, that is categorical. Jelly bean flavors, that is categorical. Country of origin, categorical. And type of meat is categorical. So make sure you know the difference between categorical and quantitative. Quantitative, we're measuring or counting. Categories, we're putting people or things into groups or categories. All right, number two. The average test score on the Unit 1, went too far. The average test score on the Unit 1 exam last year was 78, and the standard deviation was 4. What would happen to the mean and the standard deviation if the following test scores were added? Okay, so, just a second here. Okay, so
It's time to clear the hallway.
Hang on. Sorry about that. The average test score on the Unit 1 exam last year was 78, and the standard deviation was 4. What would happen to the mean and the standard deviation if the following test scores were added? So I'm going to add a 98. So the average was 78. The standard deviation was 4. So if I add a 4, then I would be at 82. If I subtract a 4, I would be at 74. So in general, most students got between a 74 and an 82. Well, what if I add a score of 98? Well, that's going to take the mean up. So the mean is going to increase. Now, the standard deviation. That 4 is an average distance from the mean. So on average, most students scored a distance of 4 from the mean. That means some were less than 4, some were a little bit more than 4. But if I add in that 98, that is a distance of 20. And so if I'm adding a distance of 20 to a distance of 4, that is going to increase the distance. So the standard deviation would also increase. All right, what about a 77? So again, I'm going to start with my 78, give or take my 4. All right, and now I'm going to add in a 77. Now, 77 is just slightly lower than a 78. So my mean would decrease very, very slightly. Now, standard deviation. The distance between the mean of 78 and the new number of 7, the distance is just 1. And so that distance of 1 has to be averaged with the average distance of 4. So that means that the distance would decrease. When I average in a 1 with the other numbers, then that's going to shrink the standard deviation. So the standard deviation would decrease. And then for this last one, We've got 78, standard deviation of 4. Got 82, got 74. Okay, now I'm adding in a 51. My mean of my distribution is going to move toward that 51, so my mean would decrease. And my distance between 78 and 51, that is a distance of 27. So I need to average that 27 with the 4. So that means my standard deviation would increase because I'm having to average in a bigger distance than the 4. So I just wanted you guys to see this, that if the mean is increasing, that doesn't automatically mean that the standard deviation increases or vice versa. So you just have to think about each of them separately. All right, number 3. The following histogram shows the actual frequency of the closing prices of a particular stock on the New York Stock Exchange. What section of the graph would contain the median? So on this, the first thing about this graph is the axes are not labeled. So I would want to make sure that I labeled my axis anytime I'm making any kind of a graph. So we've got our frequency. It does tell me that is what we're calculating, and then we have our closing price. All right, so what section of the graph will contain the median? The median is the middle number. So first thing I need to do is find out how many numbers are there in this graph. So I've got 13 plus 8 plus 15 plus 7 plus 2 plus 3 plus 1 plus 1. So that's a total of 50. So there are 50 observations in this graph. The median then is going to be at the 25th observation. So the median is at the 25th data value. So if I start collecting data values, this first one, there are 13. So I'm not at the median. The next one, there's 8. So now I'm at 21. So I'm not at the 25th data value yet. When I go to the next bar here, there's 15 total in there. So if I added 15 to that 21 that I've already collected, then I am well past the 25th data value. So my median would be in that particular bar. Now that bar is something between 20 and 30, but I don't know what the numbers are that are in there. They could all be 21, they could be 21, 25, 27, it could be anything. So I don't know exactly what the median is, but I do know that the median is between 20 and 30. All right, number 4. We have 2 data sets. Determine their shape from the information given. So really all I'm given here is the mean and the median. And so depending on how the mean and the median are related will tell me whether or not something is a certain shape. And so on data set 1, so this is data set 1, we have our mean of 34. That is less than the median. So remember, the reason that the mean would be less than the median is because the skewed data has pulled the mean down. So if my mean is down below my median, that is because I have a left skew. So data set 1 is left skewed, so it's going to be either C or D. And then if I look at data set 2, I have a mean of 131 and a standard deviation, and a median of 129. So my mean is 131, my median is 129. So my mean is slightly bigger than my median, okay? in that situation, I gotta think about, well, was there a lot of data values, or was it just a little bit, or what's going on? So it might be right skewed, but with the fact that there's only 14 observations, then it's probably going to be pretty close to symmetric. So also, there's not a right skew in the answers, so that kind of eliminates that. So we could say that it's approximately symmetric. Remember, the mean and the median don't have to be exactly equal, but they are pretty close. So especially with there only being 14 data values, that's pretty good. Number 5, the following histogram shows the heights in centimeters of 51 students at Wolford Elementary, and we need to describe the distribution. So remember, when we're describing the distribution, we would want to use SOCS. So our shape, this distribution appears to be left skew. Outliers, don't really see any. The center. All right, so since this is a skewed distribution, I'm going to want to use the median. Median is going to be resistant to the outliers or to the extreme values. So I want to use the median for this. So to find the median, I need to find the middle. There's 51 students, so I'm looking for the 25th data value. This one has 1. This one has 1. This one has 1. This one has 1. So I'm at a total of 4 for those 4. These have 2. So 2, 2, and 2. So that is a total of 6. So now I'm at a total of 10. These have 3. So adding 6 to that, now I'm at 16. So I haven't gotten to the 25th one yet. Now I've got 4 and 4. So that's 8. So now I'm at 24. And so that means that my 25th observation is in this bar right here, which is between 125 and 126. So my center, my median, is between 125 and 126 centimeters. So maybe the kid could be anything from 125 to 125.3 or 125.2 or 125.7 or whatever. So, all right, so there's my center. And then my spread. This data goes from my lowest value, which is 114, to my highest value, which is 130. And there's my spread. So shape, outlier, center, spread. Anytime you're asked to describe the distribution. Number 6, 40 students took a statistics exam having a maximum of 50 points. The score distribution is given in the following stem and leaf plot. So again, we have our key. That's extremely important to make sure you have. And we need to find the third quartile. So to find the third quartile, I'm going to first of all need to find the median of this distribution. So I'm going to do that by marking off lowest, highest, lowest, highest, lowest, highest. So I'm going to go by twos. Too low, too high. 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 High, okay. Low, high. Low, high. Low, high. Okay, here it is. So here's my median. It's in between the 31 and the 33. So that means that my median is 32. Now the third quartile is the median of the upper half. So basically I'm going to do that again, but now I'm doing that with the upper half. So top two, lower two, low, high, and wow, there you go. Doesn't really matter. It's one of those. So Q3 is 44. So now I need to know, are there any outliers in this data? So it looks like I am going to need to find Q1 as well. So I'll do that. So too high, too low, too high, too low, too low, too high, too low, and there you go. The Q1 is going to be 23. So now I have my Q1, my Q3. I can now find my IQR. Remember, that's Q3 minus Q1. So I have 44 minus 23, and that's 21. Then I need to find my 1.5 IQR number. So 1.5 times 21, and that's 31.5. Now I'm going to find out if there is a lower outlier. So Q1 minus the 1.5 IQR number. So that's going to be Q1 is 23, and then I'm going to subtract that 31.5. And what I get is negative 8.5. Well, there's no data values that are lower than that, so there is no lower outlier. And now I'm going to check my upper outlier, Q3 plus the 1.5 IQR. Q3 was 44, and then I'll add the 31.5. So I get 75.5, and my highest value was 50, so there is no upper outlier. Okay, number 7. Here is the 5-number summary for the number of fish in each of the ponds in McKinney. So remember what the 5-number summary is. That tells us the minimum, quartile 1, the median, quartile 3, and the maximum. And remember, between each one of these is 25% of the data. 25% of the data, 25% of the data, and 25% of the data. And so the question here simply says, what percent of the ponds in McKinney have between 402 and 2,000 fish? Well, that is from Q3 to the maximum, and so that is just 25%. Number 8, here are the test grades for 9 students. What are the mean and standard deviation, and interpret these values in context of the problem. So I need to find the mean and the standard deviation. I could just add all these numbers up and divide by 9, but since I know I need to get the standard deviation as well, I'm going to go ahead and use my calculator to do this. So if we go to our calculator, we're going to input our data. Okay, so to do that, we're going to go to Stat, Edit. Stat, Edit. We're going to input our data. 65, 83, 74, 90, 83, 60, 25, 85, and 88. It does not matter what order you put them in. So there's my data. And now I'll go to Stat, go over to Calc, hit enter on number 1, and then we'll hit calculate. So we can see at the very top is my mean. So the mean is at where X bar is, so 72.56. My standard deviation is where SX is, so that would be 20.598, so I can round that to 20.6. Okay, so 72.56 and 20.6. So that's my mean. And then my standard deviation, we rounded that to 20.6. So I do need to interpret these as well. So the grades were 72.56 on average, and this typically varied by 20.6. Okay, so I am going to also find the 5-number summary. Now I'm going to utilize the fact that that's already in my calculator. So remember, my 5 numbers for my 5-number summary are my minimum, Q1, median, Q3, and maximum. And those are listed in my calculator right underneath where the standard deviation was. So I'm going to go back to my calculator here. And I see that my minimum was 25, my Q1 was 62.5, my median was 83, my Q3 was 86.5, and my maximum was 90. So my 5-number summary is right there for me on my calculator. So I'm going to write that out. Minimum was 25, Q1 62.5, median 83, Q3 86.5, maximum was 90. So there's my 5-number summary. The next part of this question is asking us about outliers. Are there any outliers in this data? So again, we're going to need to check using the 1.5 IQR rule. So I'm going to find my IQR. And IQR is Q3 minus Q1. And so that would be 86.5 minus 62.5. And that's 24. Then I'm going to do 1.5 times my IQR. So that's 1.5 times 24. And that's 36. I'll take Q1 and subtract the 1.5 IQR. Q1 was 62.5. I'm going to subtract that 36, and I get 26.5. Anything lower than that in our data would be an outlier. The only number that was lower than that was the 25. So 25 is a lower outlier. Now I'll check the upper. Q3 plus 1.5 IQR. So I'm going to take Q3, which is 86.5. I'm going to add the 1.5 IQR, which is 36. And I get 122.5. There is no number bigger than that, so there is no upper outlier. Now I'm going to sketch my box plot. So first thing I need to do is make the scale. Remember, you always want to make the scale first. And I will go by tens. 25, 35, 55, 65, 95, okay. And I'm going to make sure I label this. These are grades. And my Q1 was 62.5, so that's about here. My median was 83. My Q3 was 86.5, and I'm going to connect those. I did not have any upper outliers, so I'm just going to go to the highest number, or the maximum, and that was just 90. And then I did have a lower outlier, so 25 was a lower outlier. So I want to go, for my bottom whisker, I want to go to the lowest non-outlier value, and that was 60. My scale's a little off there. So that was 60. So again, right here, this is the lowest non-outlier, and that was 60. Then I'll put a star for my low outlier of 25. And that's our box plot. All right, number 9. Here's a box plot that shows the number of Whataburgers in North Dallas cities. Remember, with the box plot, we've got our minimum, Q1, median, Q3, and maximum, and each section is 25% of the data. So even though they have different widths, there's 25% of the data here, 25% of the data here, 25% here, and 25% here. Okay? What is the range of the data? Range is maximum minus the minimum. The maximum is 12, the minimum is 1, so the range is 11. The IQR is Q3 minus Q1. Q3 is the top of the box, Q1 is the bottom of the box, and so that's going to be 9 minus 2, which is 7. The median is where the line is, so the median is 7. And then it says, what percent of cities in North Dallas have between 2 and 7 Whataburgers? What percent have between 2 and 7 Whataburgers? That is one section of the data, and so that is 25%. Number 10, we're almost there. According to the mosaic plot, so remember mosaic plots are segmented bar charts that also tell us the percentage of the distribution for each. So the reason that the student distribution is so wide is because there was way more students in the group. So according to the mosaic plot below, which group, students or teachers, was larger? It would definitely be the students. Okay, the width of this corresponds to the sample size or the number, okay? Based on this data, does there appear to be an association between the groups? So when I look at the distribution of favorite math class, it looks like my students prefer AP Stats over the teachers by quite a bit. 50% of students preferred AP Stats and only 10% of teachers preferred AP Stats. So there's a big discrepancy depending on what group you're in. Because of that, there's something going on. That means that there is an association. If I'm in different groups, it's going to change the distribution. And so that tells me that there is in fact an association. So since the distributions are different, there is an association. There's something causing there to be some difference between the students versus the teachers. Number 11, last one. Is there a relationship between Facebook use and age among college students? The following two-way table displays data for the 219 students who responded to the survey. So that gives me my total number. It says what percent of the students who responded were Facebook users. So I need to find out how many total Facebook users there were. So 78 plus 49 plus 21 gives me a total of 148. Now I want to find that 148 out of 219, and that is 67.58%. Is this percent part of a marginal distribution or a conditional distribution? That's supposed to say or. Is this percent part of a marginal distribution or a conditional distribution? Since we are using the total Facebook users over the total in the whole entire survey, I'm using two totals. That tells me that I'm in the margin. I'm in the totals margin. And so this is part of the marginal distribution. This is part of the marginal distribution. And we can even go further and say this is a part of the marginal distribution for Facebook usage. Okay. What percent of the younger students in the sample were Facebook users? We have a condition here. The condition is that they were the younger students. So I am only looking at this one part of the chart. So what percent of them were Facebook users? So there were 78 that were Facebook users out of 82 total that were younger. So I'm only looking at that one section. So 78 out of 82 is 95.12%. And then the question flips and says, what percent of the Facebook users were younger? So now the condition is that they have to be a Facebook user. So I'm in this row of the table and nothing else is going to matter. So what percent of those 148 people, what percent of them were younger? 78 out of the 148 Facebook users. That is a percent of 52.7%. Okay, now we're going to make the segmented bar graph. So to make the segmented bar graph, sometimes it'll tell you which one to use as your conditional variable. Sometimes it won't. If it doesn't, like this one does not tell you which one to use as the condition, you get to pick, okay? So for this one, I'm just going to basically use the condition of age because I think that age is going to give me an indication of whether someone is a Facebook user. That's kind of maybe the suspicion. So the first thing I'm going to want to do is I'm going to want to make sure that I know the percentages based on age. So if I do age, basically kind of remaking the chart here. And then whether or not they're a Facebook user. All right, so my 18 to 22-year-olds, so I'm going to look at the total for the 18 to 22-year-olds, that was 82. And there were 78 of those 82 that said that they were Facebook users. So that's 95%. That means that the rest are not Facebook users, 4 out of 82, and so that's 5%. So because I'm doing age as my condition, these should add up to 100%. Now I'll look at the 23 to 27. So it's 49 said yes out of a total of 70. And so that is 70%. Then for no, there was 21 out of 70, so that's 30%. And again, because I'm using age as the condition, those should add up to 100%. And then finally, I had 21 out of 67, that's 31%, are 28 plus that use Facebook. And then 46 out of 67 is 69%. And those should add up to 100%. So the condition, which I'm using age as condition, is going to go on the x-axis. So 18 to 22 23 to 27, and then 28 plus. And every segmented bar chart has a y-axis from 0 to 100%. So these are my percentages, and these are my age groups. Now, I'm going to make the bars based on age and category here. So we've got 95% said yes in the 18 to 22, and then I'm going to stack that bar for no on top, which is just a small little 5%. Then I'll do the 23 to 27, so that's 70% for yes. And then I stack the 30% on top. And then for the 28 plus, I've got 31% said yes, and 69% said no. And then the last thing I need to make sure I do for my segmented bar chart is to make a key. So the red box means yes, and the blue box means no. And that is for Facebook use. So there's my key. So there's my segmented bar chart, and I can answer this final question. Do you believe there is an association between age and Facebook use? So when I look at my segmented bar charts, there is definitely a difference. If I'm in the lower age group, probably pretty likely that I am using Facebook. If I'm in the 28 plus age group, probably a pretty good likelihood that I'm not using Facebook. So there appears to be an association between what your age is and whether or not you use Facebook. So the answer here would be yes, since the distributions are different, an association likely exists. Alrighty, so make sure you guys continue to study, and good luck on your test.